discovery education, wherein you answer about the exponential and the logarithmic function that we have in your discovery education. So for this afternoon, we're going to discuss the 5 properties that we have for the logarithmic function. That is, we have four basic properties of logarithms that will be working with every case or the base of the logarithm that is not equal to 1. Cannot be equal to 1. So we have four basic rule or basic properties that we're going to use to expand and compress the logarithmic function that we have. We also use this in your exponent rule. If you still remember the exponent rule, naalala pa ba ang exponent rule? Rule of exponent. We're going to use that to expand and compress the logarithmic function that we have. So let's start with the first properties of the logarithmic function that we have, which is the product rule. So in product rule, the same in the law of exponent. When you are multiplying an exponent, you add the exponent, right? So the same with the logarithm. Once we have a function or a logarithmic function indicating a multiplication operation, to expand the logarithmic function, you're going to use the operation addition to expand your logarithmic function. For example, we have this logarithmic function, logarithmic t, x, and y. So to expand this logarithmic function, the rule is just you're going to separate the logarithmic xy with the same base, which is the logarithmic d. Okay, so you will be having logarithmic dx plus logarithmic dy. So that's how we expand the logarithmic function. Another example, for example, we have logarithmic 6. So we're going to expand the logarithmic 6 using the product rule. Okay. So we will be having logarithmic plus a logarithmic. Since the base, we don't have a base for our logarithmic. It has an invisible 1 base. So you have logarithmic. So we have 6 as our argument for the logarithmic function that we have. So factor out this 6. What is the factor of 6? 2 and
Okay.
2 and 3. So you have to expand this function, logarithmic function 6. You will be having logarithmic 2 plus the logarithmic 3. Okay? So that's how we use the product rule for the logarithmic function, expanding the logarithmic function that we have using the product rule. Another example, for example, we have the logarithmic 3, 9b. Okay? So we're going to separate the argument of our logarithmic function, which is 9b, to expand our function. So you are going to have the logarithmic 3, 9 plus logarithmic 3b. So that's how you expand the logarithmic function using the product rule. Okay. Question about product rule? Hindi na. Kapag we only have one argument, just like 6, we have one argument, that's the time you're going to factor. But if it has two numbers or it has a variable, no need to factor the 9. Okay? So that is the product rule, the first properties of the logarithmic function. So let's proceed with the next properties of our function, which is the quotient rule. So the same in the quotient rule of exponent. When we are dividing an exponent, we subtract the exponent. Am I correct? In the law of exponent. So we're going to use that also in the function rule of our logarithmic, wherein when you are dividing two function, you subtract both of the function that we have using the same base of your logarithmic function. For example, just like here, we have the logarithmic function 5x and y. So we separate the argument to expand our function, which is logarithmic 5x minus logarithmic 5y. That's the only thing that we're going to use. Since quotient rule, in the exponent, we subtract the exponent rule or the exponent when it comes to the exponent rule. So we're going also to subtract both the argument that we have in our function. Another example, using the quotient rule to expand. For example, we have the logarithmic 2a over 5. So we're going to expand this logarithmic function using the quotient rule. So we will be having logarithmic 2a minus logarithmic 2 5. So that's the only thing that you're going to do in expanding the logarithmic function that we have. We're not going to solve anything. Just remember the rule that we have in the properties of function. Okay? Another example, we have this function. For example, we have the logarithmic mn over p. As you can see, in the first argument that we have, it has mn. But what is the first rule that we have?
Log A mn.
The first rule is the product rule. So to expand this function, we need first to expand this argument that we have, which is mn, using the first properties that we have, which is the product rule. So let's expand first this mn. We have logarithmic 2m. What operation is involved when in our product rule?
Plus
Plus the logarithmic 2n minus logarithmic 2p. That is the expansion of the logarithmic function 2mn over p. Why is it that we separate m, and n? Since this is two argument or two function we have here, which is m and n, or m times n. That's why we expand this argument, which is mn. It will become logarithmic 2m plus logarithmic 2n minus the logarithmic 2p. So sum of the functions, it may combine all the properties that we have in the function. The same with the example that we have here, which is the logarithmic 2mn over p. Okay? So that is the quotient rule that we have for the logarithmic function. Third properties that we have. So we're done with the quotient rule. The next properties is what we call the power rule. So in power rule, the exponent of the function, the logarithmic function that we have, will be the base, just like here, x logarithmic b m. So you get the exponent from your argument, and Add it to the base of your logarithmic, so it becomes x logarithmic b m. For example, logarithmic 5b squared will be equal to 2 logarithmic b logarithmic 5b. So another example for power rule to expand our logarithmic function. For example, we have logarithmic 2, 5 raised to the power of x is will be equal or the same. Once we expand it, it will become x logarithmic 2, 5. So another example for power rule, we have the logarithmic 7a cube times b raised to the power of 4. So looking at this function that we have, it has a combination of two properties of function, which is the product rule and the power rule. So let's start with the A argument. Just expand this A cube in the function that we have. So we will be having 3 logarithmic 7a, since it's a combination of product rule, so plus 4 logarithmic 7b. So that is the expansion of the logarithmic 7a cube and b4. Okay, question in the power rule. We're not solving anything, huh? We're just expanding the function that we have.
Sure. Another example, please.
Another example for power rule. For example, we have this function, logarithmic 3 x squared and y cubed. For example, that is the function that we have. And we need to expand this logarithmic function that is given. So let's expand. So let's start with the first argument. Expand your first argument, which is x squared. So if we're going to expand this function, it will become 2, get the exponent of your argument, which is 2, logarithmic 3, and your x. Then proceed with your second argument, which is y cubed. So since x and y is in a rule of product, so we're going to add. So plus, get the exponent of your second argument. So 3 logarithmic 3y. So that is the expansion of logarithmic 3x squared and y cubed. Okay? So let's proceed with the last properties that we have for the logarithmic function. So properties of logarithmic, we have the product rule. So the condensed form of the product rule is logarithmic a mn, or the expanded form of the product rule is logarithmic a m plus logarithmic a n. And for the quotient rule, you have this expanded and condensed. And for the power rule, that is the expanded and the condensed form of the properties of the logarithm. So let's try this following function that we have to expand the logarithmic function using the properties that we have. So for example, we're going to write the following logarithmic function into condensed. It's already expanded. So let's start with this expanded form of function, and we're going to condense or shorten this function that we have. So we have logarithmic 4 minus the logarithmic 4 and 16. So what rule is being used in this expanded form? The quotient rule. So if this is quotient, we're going to condense or shorten this function. We will be having logarithmic 4 over 16. Can we still simplify 4 over 16? Yes. What is the simplified form of 4 over 16? 1.
Okay, you're choking, stumble, mumble, and fumble like peanut butter.
Okay. So we have 1/4 as the lowest term of 4 over 16. So we have 1/4 as the shortened form of the expanded logarithmic 4 minus logarithmic 4 over 16. What about this second function that we have? What will be the shortened function of the logarithmic 5 plus logarithmic 2? What rule are we going to use or being used in this function, expanded function that we have?
Logarithmic 10.
Logarithmic 10. We will be having logarithmic 10. Since addition is an indication of our rule, which is the product rule. So 5 times 2 is 10. So we have logarithmic 10 as the shortened or condensed form of our expanded function. What about this one? What is the condensed or the shortened form of the function 2 logarithmic 2m minus 4 logarithmic 2n?
Logarithmic
Logarithmic
m
The collision of obstacle
squared
courses, or
m
squared
squared
n
n
to the fourth power.
to the fourth power. This is the condensed or shortened form of the logarithmic 2m minus 4 logarithmic 2m, since it has a combination of your power rule and the quotient rule, or there are combination of two properties of the function that we have, just the quotient and the power rule. So that is the shortened or the condensed form of the function that we have on the screen. So let's have another example. Okay na? Can I clear the screen? Okay. So for example, we're going to condense or shorten this expanded form of logarithmic that we have. So let's start with the first one. We have logarithmic 5 plus logarithmic x minus logarithmic 3 plus 4 logarithmic 5. So you can see it's a combination of the all of the properties that we have, the three properties, the product, the quotient, and the power rule. And we're going to shorten this expanded form of function that we have. So let's start with this. Let's start with these two properties. Let's shorten this one. Logarithmic 5 plus logarithmic x. So this one, use the product rule. So we will be having logarithmic
V.
logarithmic 5x. Okay. After that, let's proceed with this one. Combining the minus logarithmic 3. So since it's minus, that means it's a quotient rule. So divided by 3 and then plus the logarithmic 4 4 logarithmic of 5. 4 logarithmic of 5 use the power rule. Am I correct? 4 logarithmic of 5. This one, it uses your power rule. If you're going to write this one, it will become 5 raised to the fourth power. But it also has a product rule since it has addition. So we're going to have 5 to the fourth power. So we have logarithmic 5x over 35 to the fourth power. So let's proceed with the next example that we have. So let's condense or shorten this expanded form of function, which is logarithmic 4, 5 minus the logarithmic 2 or x plus 5 times the quantity of logarithmic 4, 3x minus the logarithmic 4, 5x. So let's shorten. Let's start with this 2 function that we have. So we will be having logarithmic 4. Since it's subtraction, that means the operation that is being, or the rule that is being involved is the quotient rule. So you will be having 5 over x squared. So let's proceed with this 1. We have 5 times the quantity of the logarithmic 4, 3x minus the logarithmic 4, 5x. Let's start with the terms that is inside of our parentheses, which is logarithmic 4, 3x minus logarithmic 4, 5x. So we will be having 5 logarithmic 4, which is 3x over 5x. I only shorten the one or the terms that is inside of our parentheses, which is logarithmic 4, 3x minus logarithmic 4, 5x. But we're not yet done since we still have 5. So 5, what are we going to do with the 5? Since it has an operation or the quotient rule, which is addition plus 5. So logarithmic 4, 5 over x squared plus 5 times the quantity of logarithmic 4, 3x minus 5x. Can we still shorten this function? So this is already the shortened form of our function. Logarithmic 4, 5 over x squared plus 5 times the quantity of logarithmic 4, 3x over 5x. Yes po. We get it from here, from the logarithmic 3 plus 4 logarithmic of 5. Since the operation or the properties that is being involved with these two functions, the logarithmic 3 and the 4 logarithmic 5 is product rule. That's why we get 35. So if we're going to solve this 35 raised to 4 or multiply 3 times 5 raised to the 4th power. Let's have another example wherein we shorten and expand our logarithmic function. So for example, we have this one.